Before I got into the meat of my talk, I thought it might be good to talk a little bit about just some general things so we're all on the same page. And this is about the sort of the interactions that I'm working on, the work interactions between the 728 range load standard and NOAA Atlas 15. But just to orient everybody, this is actually a table from NOAA Atlas 14, happens to be for Asheville. But what does NOAA Atlas 14 have in it? Well, it has precipitation amounts that are exceeded based on as a function of duration of the event and average recurrence interval. So Atlas 14 includes durations that go from 5 minutes out to 60 days and average recurrence intervals that go from 1 to 1,000 years. So for example, what's the interpretation of that? If we take the 24-hour duration and the 10-year recurrence interval for Asheville, we get 3.87 on this table. What that means is that a rain amount or a precipitation amount of 3.87 inches over a 24-hour period occurs on average about once every 10 years. Or we can put this in a different framework, and that is a probability framework. And the probability framework, which was kind of terminology used as annual exceedance probability, this amount would be exceeded, or the probability of this amount being exceeded in a year is 10%, or essentially 1 over the average recurrence interval. So what is the ASCE rain load standard? Well, it's a subset of this. It's one particular cell in this matrix. It's for a 15-minute duration for an average recurrence interval of 100 years, or annual probability of exceedance of 1%. So for Asheville, that value is 1.51 inches. Okay, so with that as background, the work that's going on now is to incorporate future climate change into these standards. So for Atlas 15, this is just a mock-up. These aren't real values that'll be in Atlas 15, but Atlas 15, so probably everybody on this call knows, is going to have 2 volumes, Volume 1 and Volume 2. Volume 1 will be an update of Atlas 14 values with the added nuance that they will incorporate non-stationarity and into their values, non-stationarity in the historical record. At Volume 2 will incorporate future projections. So for example, and again, this is just a mock-up, so these aren't real values. If you look at the table on the lower left-hand or lower right-hand corner, this potentially would provide values for the 60-minute duration for various annual exceedance probabilities from 100% down to 0.1%. And this is the exact set of, or corresponding to Atlas 14, except it's in this probabilistic language or framework. So for example, if we were interested in the 1% AEP, which would be equivalent to the 100-year, there will be an updated value that's been updated. That's listed here as the most recent value. And then there'll be various options for looking ahead into the future. This particular mock-up includes 2 scenarios for mid-century. And in general, those values will be higher in the future than they are for the current. So now I'd like to just talk a little bit about the rest of the talk is about my involvement in these 2 ongoing projects. And I'd like to just first of all start with a timeline of how I've been involved. For ASCE 728, I was asked to give a talk at an ASCE Structural Engineering Institute Climate Impacts Workshop a year ago in May. And I developed some recommendations. I'll go through those in just a minute. I also attended the in-person final session of this Climate Impacts Workshop series in October of last year. Then in May, there was a panel discussion on 728 at ASCE SEI Structures Congress in New Orleans. I attended that Congress, and I was a member of this panel. And in my panel discussion, I essentially reiterated the recommendations that I had given in a year before that. And then just this past October, I attended the Future Conditions Subcommittee meeting in Boulder. So what were my May 2022 recommendations for the range standard? Well, was to identify and deploy resources to analyze available data sets from convection resolving climate model simulations. And I'll get into that in a little more detail later, but because of computational demands, there is limited availability. The second part of my recommendations is that to incorporate future change, we do this as an adjustment to the historical values rather than independently calculating future values from, say, climate model data. We actually use the climate model data to compute an adjustment. Maybe it's 15% higher, for example, in the future from our climate model data analysis. And that 15% would be applied. And at that time, we had NOAA Atlas 14. I didn't know that NOAA Atlas 15 would be coming along so quickly. So it would be applied to NOAA Atlas 14 values. So if the value were 1.51, as we had in for Asheville, and we had a 15% adjustment factor, then the value would then be like, I got to do quick math in my head, maybe 1.72 or something like that inches would be the future adjustment factor for a particular scenario and time frame. At that point, I had identified some possible data sets that could be used for this. These are all convection resolving climate model simulations. There's NCAR's CONUS 404 simulation. University of Illinois and Argonne National Laboratory have teamed up to run CRCM simulations. And there are also UCLA, Alex Saul has been doing some for the Western US. So those are what I had identified at that time. Now, what's my involvement in NOAA Atlas 15? At the beginning of this year, I was asked to prepare a research proposal to provide research support for development of Volume 2, the future projections part. There was a tentative award to North Carolina State University in summer. And then since late summer, I and my team have been actively working on initial project tasks for Volume 2. So more specifically about my role in NA15 Volume 2, once again, my proposed approach is to use climate model simulation data to calculate adjustment factors, and that these adjustment factors would be applied to the new values that are being developed in Volume 1. Two of the foci of my research are on short duration estimates, specifically sub-daily durations, and also small annual exceedance probability estimates. So now I'd like to spend some time on particularly the short duration estimates. The 728 standard squarely falls in this in this area. As part of the research I'm doing, we are analyzing downscaled climate model data sets, particularly two that we used in the 5th National Climate Assessment, LOCA2 and STAR. And we also have a third one we're incorporating, which is University of Wisconsin probabilistic downscaling data set. What's perhaps most relevant about this is that all these data sets provide daily precipitation. So they're suitable for looking at future for 24-hour durations and longer, and maybe down to this is sort of very fuzzy, but maybe down to the 1 to 2% annual exceedance probability range. Because they're daily, they don't directly address the sub-daily timescales, the durations, In addition, there's very limited CMIPS data availability in CMIP6 at sub-daily resolutions. So how can we address this? And what should we expect? I guess I've been kind of operating under a NOAA hypothesis, is that we want evidence that short duration changes, relative changes, will differ from the longer duration. So that the question is whether that's the case. The NOAA hypothesis might be that they don't. If there's a 15% adjustment at 24 hours, maybe that should be applied all the way down to the shorter durations. But different physics can certainly be operating. The super-Clausius-Clapeyron effect, where upward motion in convective towers is enhanced by increased latent heat release, that might be more important at shorter durations than at the longer durations. There's also potential changes in weather system characteristics that might differ at the shorter durations than at the longer durations. One issue with all climate models with regard to precipitation is that many processes have to be parameterized, and perhaps one key one is cumulus convection. And in typical models, this is parameterized, whereas in convection resolving climate models, they actually, as the name implies, resolve individual convective towers in weather system, precipitation producing weather systems. So you sidestep to an extent the uncertainties that might arise from choices about cumulus parameterizations. So based on current funding that I have, I'm planning to analyze the NCAR CONUS 404 simulation data set. I've also been able to get access to another, the CONUS 404 simulation is 4-kilometer spatial resolution. Northern Illinois University has generated a 4-kilometer resolution data set, and I've gotten access to that data, so I'm planning to analyze that. Also, I am planning to analyze the NA Cordex simulations. They provided access to hourly data, so we get pretty far down the duration scale and pretty close to the 15-minute standard. These are 25-kilometer resolutions, so they're not convection resolving, but I would like to look at these and see what they produce. Time frame, the analysis of these convection resolving climate model simulations and the NA Cordex will continue through the period 2024 to 2026. Thus, adjustment factors may evolve during that time. Now, March 2025 is the ASCE deadline for a review draft. This will be in the middle of work on both Volume 1 and Volume 2 in Atlas 15. Preliminary values for Atlas 15 are scheduled for release by September 2025 for peer review. Adjustment factors may evolve into 2026 based on continued research on my end and potentially response to review comments. So what does this mean for the 728 standard? Well, a couple questions immediately arise, and these came up in our recent future projections subcommittee discussions in Boulder. Do actual final 15-minute 100-year values have to be available by March 2025? Or can the March 2025 review draft have interim values, but with flexibility to update to the NOAA Atlas 15 Volume 2 values before the release of 728 in 2028? And that's my presentation. I'm happy to have discussion and questions.
Well, thanks, Ken. I appreciate the two questions that you identified. I was hoping you had answers.
Well, I have a preference. I don't have answers, but
well, I mean, what do your colleagues on ASCE 728? How would what would be their answer to these questions, do you think?
Well, I don't know. I would say, and the people who were at the October workshop could weigh in and have additional context, but, and of course you were there too, but first of all, I think our small group that met at Boulder thought that the second option made a lot of sense. That, we have, the proposal would be to use NOAA Atlas 15 Volume 2 values, and we provide some preliminary, values before March 2025. When we got into more plenary session discussions in Boulder, it seemed maybe that didn't fit the way things need to happen in ASCE for the 728 volume. So it seems to me for me, from a common sense perspective, the second option here would make the most sense. Then both 728 and NOAA Atlas 15 volume 1 and 2 will be. So there, you got it. There's my.
All right,
that'd
thanks,
be my
Ken.
recommendation.
I have follow-up questions, but I'm going to let Bilal go. He's got his hand up.
Thank you, Ken. That's very helpful. I really appreciate it. You showed us how would the future layout of the portal or the results will look like. But I want to understand, maybe was that coordinated with ASCE in the sense how far in the future we have to go, what scenarios we should be covering? I thought they were talking about maybe using temperature to define future scenarios, and you covered, I think, mid-century and late century. And is that adequate? Or I don't have the answers, and maybe you don't, but or should we go another quarter? We're already wrapping up the first quarter of this century.
Yeah, I don't think we have the NOAA Atlas 15 group has the definitive final thing, but I think in general what NOAA Atlas 15 will be, and there'll actually be two things. One will be, we'll actually have values for global warming levels. So 2, 3, 4, maybe 1.5. So you can actually kind of get out of time and scenario space and look at just global warming levels. And then we will have an option for, maybe a couple scenarios and a handful of times into the future, so you can have some choices. Although the latest discussion that came out is that I think the plan is actually to give great flexibility for time frame, that there can be a choice, somebody can choose any year into the future for maybe a couple of scenarios, 2 or 3 scenarios, and you actually have all of that. And so you have NOAA Atlas 15, actually a lot of flexibility for choice. You have a lot of choices.
Right. That makes sense, Ken. And just so I can make sure, because, we bounce back and forth between NOAA Atlas 15 and ASCE 728, and they're two separate but interrelated activities. So you're talking about a portal that would support the dissemination of data from Atlas 15 there, right? Where you would have because the user groups are so diverse, one size is probably going to fit all.
What this is it's just a mock-up. So please keep that in mind.
Right.
But it's just a mock-up to show how the NOAA Atlas 15 website might operate and look. And right. Fernando here online could probably, or Fernando or Sandra could, provide any. Please correct me if I'm saying something I shouldn't.
Right. I said Fernando's got his hand up, so we're going to cue Fernando here.
Yeah.
Yeah. No worries, Ken. Everything you've been saying is correct. And so, with regards to the Atlas 15 timeline, part of, we've been talking about doing this Atlas 15 pilot over Montana come this summer. And as part of that pilot, what we're going to be doing is releasing this web interface, similar to what the mockup is showing here, to disseminate those Atlas 15 data sets for Montana. So, part of the feedback that we're interested in getting from the pilot is not only on the data itself and the methodology, but also how we're disseminating this information through the visualizations or the data services that come with it, so that it can be easily accessible and utilized by the community. So yeah, we're taking steps now to implement what's mocked up here on the screen as part of a new website that we are launching in 2024, which is called the National Water Prediction Service, or NWIPS. And part of NWIPS will have a precipitation frequency section, which will start disseminating some of the pilot information. But again, yeah, this is the feedback that we're interested in getting, is not only the data, the quality of the data, the methods, the use of climate information in the models, but also how we disseminate this information out.
Right. That's great, Fernando. And I know that ASC, there'll be a lot of communities within ASCE that'll be interested in that pilot. Joe?
I just want to follow up a little bit on that. I'm trusting, Fernando, that you're going to be having like an API or something like that, because currently the ASCE 7 hazards tool, grabs the data. I don't know whether they have the data staged at the hazards tool, but I think they actually grab it through an API, right? So a web a data transfer protocol, right? With standards. I presume there's going to be some service like that with this, right? Where you could just, I want this data from your bank and I can bring it into my own world.
Yeah, I think we're still discussing some of those strategies, but yeah, ideally either an API would be nice, or use of cloud technology where we can post things in cloud optimized formats on like S3 buckets, let's say in ZAR format or something that already has an API embedded to make the queries like what you were just speaking to. So we're still trying to figure out what the solution space is, but yeah, some type of web interface or service implementation is what we would like to get to.
And because when we had our workshops, one thing that a lot of people seemed to like was the idea of serving this data through an ASCE portal, such as the ASCE 7 hazard tool. And if you haven't ever gone there, I think it's really instructive just how useful that combines a lot of information for engineers. So facilitating something like that would, it just was like really bubbled up as like, hey, yeah, this is a great example of how it would get into practice with, this person who has a medium-sized project to deal with.
Gotcha. So yeah, I'm not familiar with that particular portal, but maybe that's something that we could demo in one of these future calls, and that could inform, how we make, how the data that we serve and publish, right, can easily or seamlessly integrate into that type of portal to facilitate.
Then at the bottom, it links to the NCEI, and frequency tables and stuff like that, but it pulls out just the data that's needed for the standards.
Gotcha.
Yeah, it's really
okay. Cool.
Right. Allison?
Yeah. Hi, Ken. Good to see you again.
Yeah.
And thanks as always for a very clear presentation. I was wondering if you could comment on model weighting, and if that's something that you have or haven't considered, and what the different perspectives were on that, both that in the work that you're doing.
What models that I'm using?
Model weighting.
Model weighting. Well, that's a question that, good question, because of course we use model weighting for many of the products in NCA 5, and we did it in NCA 4. So I guess the question would be, should we use this in NA 15 and 7? Well, it doesn't, particularly the 24-hour and longer durations in NOAA Atlas 15. And probably what I would probably do, unless there's, our, project team group has a different opinion, would be to put the values out there with model weighting and see what kind of comments we get back in the peer review process. Whether people think that's not a good way to go or what. So that'd probably be my response to that.
And you would use then the same model weighting that you used for NCA 5?
Yes.
Okay.
Yeah. Because that's published and it's out there. So, that would be what I'd, if we didn't use that, in the absence of anything else, I probably wouldn't use model weighting if we didn't use that.
Thanks.
Bilal, I saw you just dropped the question in the chat. Why don't you go ahead and verbal that one so that Fernando maybe has a chance to respond?
Yes, I'm happy to do that. No, I asked about, I'm just curious, a building code or a standard, the timestamp with Don Scott and the leads in ASCE 7, they emphasize how important the timestamp it has, legal implications and all of this. And I was wondering, how would that fit in the Atlas 15 updates? Would it follow because now we have non-stationarity, so would it be done in the cycle of national climate assessment, or how frequent? And let's say if there is a release of it, what will happen to the older version if somebody's using it in design? I'm just thinking in terms of that timestamp and what's the implications. Thank you.
Yeah, so I guess I would say one, I mean, the authoritative timestamp would be the publication date of the information, and the technical reports that summarize the methodology and how the data was generated would also document various different climate models that were run, and the time periods that were utilized, and as well as all the observation data. So I think you're right. I mean, this needs to be fully documented so that we can clearly understand the temporal aspects of this, especially in this new non-stationary world. With regards to Atlas 15 updates, so the bipartisan infrastructure law provides the funding to do this initial version of Atlas 15, which would publish the final results of over CONUS in 2026 and then the OCONUS areas in 2027. Although NOAA has received the authorization and is being asked by Congress to continue updating Atlas 15 no less often than once every 10 years, NOAA has not received the appropriation or the funds to update Atlas 15 beyond this initial update in 2026 and 2027. So we're not sure what's going to happen after that. If funding were to be provided to NOAA, then our goal would probably be to provide another update 5 years after 2026 or 2027, something like that. I mean, the law says no less often than once every 10 years, but I think in conversation with you guys, coming up with a good update frequency is something that obviously we can work with you on, whether that's 5 years or 10 years or 7 years or whatever.
No, that's great. And Ben, I'd like to do a quick follow up with Fernando here. It's kind of I'm curious. I mean, obviously, volume 1 is a pretty heavy lift because some of those Atlas volumes were completed quite some time ago, and so doing everything uniformly across CONUS and OCONUS was obviously a pretty big lift. Just from a technical standpoint, do you think that the 5-year update is that going to be more manageable? I'm just kind of curious because I could see how that might come up.
I think it's dependent on the level of appropriation that is provided to support those updates. If it's fully funded, then perhaps 5 years could be manageable. But if the budget is not at the ideal level, let's say, then maybe it'll take a little bit longer. So it just depends.
Right. Okay, now that makes sense. And I know that the value of these data sets for ASCE members, that's why ASCE I think was involved in the Precip Act and the Floods Act to kind of promote the work by NOAA. So I know that this is on the minds of our government relations staff already. And so at some point we probably need to have some kind of a conversation about how to frame that, the mechanics of that in such a way that ASCE can advocate. Ben, did you have your hand up?
Yeah, thanks. I did want to ask just kind of the NCA related questions. One I was wondering, Ken, if you can say a few words about the current Atlas 15 approach, its its relationship to what we have in NCA 5, and then just going forward, just wondering if we can think more about how to leverage what will be an ongoing effort to update NCA 6 and NCA 7, and that is on a fairly predictable time frame because you have the congressional mandate to do it on paper every 4 years. It's not always exactly 4 years, but 4 years thereabouts. Anyway, just also some thoughts about how we might be able to leverage that and kind of maybe sync up that effort for future Atlas updates.
Well, first of all, from the NCA perspective, both NCA 4 and NCA 5, we did, my group, I did it for NCA 4 and my group did it for NCA 5, calculating, kind of future projections of extreme precipitation and having some products that we could incorporate into the report. I think what the NOAA Atlas 15 work, we're developing, kind of, not that we did, I would say we used modern techniques in NCA 4 and NCA 5, but I think the techniques that we're now implementing for the NOAA Atlas 15 are not only state of the art and whatever, but I think are probably a little bit easier to sort of make updates as new data sets come in. And for NCA 5, we could incorporate, I could see things like NOAA Atlas 15 Volume 2 and update to those kind of products into future NCA 5 updates. And it actually could feed back into an update of NOAA Atlas 15, where we get new model data sets and we use the same analysis techniques. And let's say a new, probably for NCA 6, I don't know that we're going to have CMIP 7 stuff available yet, just because of the timing. But as soon as if new downscale data sets become available based on CMIP 6, those could be incorporated very easily into sort of doing incremental updates of NOAA Atlas 15. And then for NCA 7, when we would have CMIP 7 for sure, we could do maybe a more wholesale update using the same sort of computational framework we're developing for Atlas 15. Did that answer your question, Ben? I don't know if that's...
Yeah, that's helpful. Thanks, Ken.
Okay.
Joe, you had your hand up and then you took
Oh,
it down.
I'll let Sihan go first since he hasn't spoken.
Okay.
All right, Ken, I do have kind of like two questions. The first question is, I'm just curious, what is the methodology used in this latest Atlas 15 to consider the non-stationality from the future projections? And was that still similar? Kelly is using a window for the future period, and then just to do the typical RDF analysis or curve analysis, or with a full probabilistic non-stationary analysis has been carried out, which is different than the conventional methodology. And my second question is how. So in a stationary climate, either using the mean recurrence interval or annual exceedance probability or lifelong exceedance probability, they're equivalent. And now for the non-stationary climate, those two things may not necessarily equal, especially if the non-stationality becomes very severe. And if there is any plan in this tool would give designers an option whether you want design against or annual exceedance probability, or you would more prefer to design a lifelong exceedance probability or total reliability of your infrastructure. Is there any plan to incorporate that, and whether there's a guidance for the designer to do that kind of exercise?
Yeah, I think that maybe answer your second question first. I don't think there's this lifetime integrated approach is being planned, but that doesn't mean you know, if you have any suggestions on how we could do that, that would be actually welcome as far as I'm concerned. For the first question, the current plan that I have is, and it's kind of connected to how they're doing historical analysis, but to use a GEV non-stationary framework with probably global warming level as the covariate to do the GEV fit, and to apply that framework to our future model simulation data, probably applied to the annual maximum series. We're looking at doing it to the partial duration series also. And then once we have that kind of backing into, that would provide us sort of a direct estimate at various global warming levels. If we want to show 3 degrees C, we can combine those from the various model sources. And then probably using a table lookup type of procedure to get back into scenario and time, the time framework. As far as what uncertainty or since for the statistically downscaled data, what I'm planning to incorporate into that would be multi-model spread, or perhaps a standard deviation metric for the uncertainties that arise from sort of model uncertainties.
Did they get it, Sihan?
Yeah, that's great.
Okay, thanks. All right, Joe, you're up.
Yeah, this is quite related to that. Sihan and I connected at the Inspire meeting about the non-stationarity, and that was sort of one thing I really went to a bunch of sessions, just trying to observe how non-stationarity is being, you know, dealt with, or how engineers are struggling with designing in a non-stationary climate. And so Sihan and I connected about that. We're probably going to be doing some sort of at least investigation, and probably a paper about these suggestions, because he presented several options. And it's good to know that this is something that can feed back into the presentation. I mean, for example, if you had non-stationary GEV, then publishing the parameters as well would allow someone to dig deeper, right?
Yeah, that's right.
So that would be really, really an important way to allow an engineering design to be more sophisticated than just picking out the minimum number from the standard.
Yeah.
So what I wanted to say about that, though, was the uncertainty question is the other one that I wanted to address. When you look at the existing Atlas 14 and you see a number, and then you see the range of numbers underneath that, I went into the whole publications of that. That is simply the parametric estimate of the statistical fit. It is not, there's no structure, there's no uncertainty of statistical fit to that. There's no other uncertainty in that I know of. I guess there was another little bit of uncertainty about measurement error, but it does not count even the epistemic uncertainty, as engineers would refer to it, as to the appropriate fit. And it was done by choosing a fit from a number of different probability distributions and finding the best fit among those distributions, and then showing the parametric uncertainty. And I do think that leads to the ability to underestimate. I did this right after the 2013 floods here, saying, was it within the realm? And so I'm a little bit concerned when we have now more epistemic uncertainty, the model structural, the climate model uncertainty, just how that, I know you just sort of said, well, we might do this, I might model right. I think that needs to be handled very transparently and really openly, because I think that is a really potential bone of contention as to that, those who want to dig beneath the central number and into that uncertainty range. That's all I wanted to say about that, because I think that's a really important thing to start early and have your proposal out, particularly this summer, right?
Well, yeah, and I would say probably, just because I don't have any better ideas at the moment, probably what I would propose doing is the uncertainties that arise from the multi-model spread would be added to the uncertainties in the, in the historical values, And I did this for my CERTA project, and our website that we developed for that, we don't just simply add them, but we, kind of statistically kind of the school, square root of the sum of squares kind of approach to add these additional layers of uncertainty. And it, certainly widens the uncertainty range. And
I just think engineers have, my experience now has been engineers are way more sensitive about how uncertainty is calculated than scientists are, because it costs money, right?
Yeah.
So I'm just thinking that that whole process really needs to be something that is out there early for comment and discussion. I mean, I think your idea is right, but I also think distinguishing between the estimation uncertainty given just randomness and sampling and this sort of model choice, which is not the same kind of uncertainty. I think it's important to distinguish those at some point. That's just my commentary on that, but
yeah, so maybe it should be separately and in
I don't know,
combination.
just figuring out how to work through this with the engineers, because it's really going to be a two-way dialogue on this.
Yeah.
All right, thanks, Joe and Ken. I guess my one comment there is, and I think everybody needs to kind of keep this in mind. I know you always do, but I'll just reemphasize. There's kind of engineers writ large, and then there's what is required for a minimal design standard, which is kind of what ASCE 7. That's what ASCE 7 constitutes. So, there's a lot of complexity here, and we just kind of need to work through that a little bit. I guess does anybody else have any questions or comments? Because Kelly, I actually have a question for you. You've been involved in the Academy's study on probable maximum precipitation. I know you don't have access to their closed deliberations or outlines or whatever at this point, but do you get a sense that have they been having conversations about how to treat some of the underlying issues, like what time frames and what are we going to use warming degrees or scenarios? Do you have is this broadly consistent with what you've heard?
I literally, for like the last 8 months, my monthly updates have gone like, what do you want to know? And I'm like, well, I want to know what you can tell me. And they're like, oh, we can't tell you anything. So I really don't know. But if I had to guess, based on sort of like the kickoff meeting conversation where I was able to talk to the committee, I don't think, if they include anything along the lines of what you're asking about, Dan, it will be very general. And I think that they will leave it to what's going to look something like this kind of a process, like the implementation, the production and the implementation of it, to us. I think their recommendations are going to be more broad about the overall approach and sort of the overall thinking of how to essentially, I hope, overhaul PMP. So no, I do not think they're going to get as granular as how to deal with degree days and stuff. I could be surprised, but that's my hunch. I really don't know though.
Okay, well, I guess the one question then that I would have is, would the presentation like this to that committee be helpful? Because I think what would be desirable is that the Academy report doesn't come out and drive debate about what might be considered settled with regard to this project. But
yeah,
that's just me. That's just me kind of trying to avoid the worst case scenario, I guess.
Yeah, no, so you're hitting on something that feels incredibly ripe and relevant right now. So they are, in terms of your question about would a presentation like this help for them, they're in the thick of writing right now. They need to complete their draft for internal or for peer review by the end of January. So I don't think they're really intaking a whole lot more. They're more like digesting what they've already gathered and writing. However, what I failed to mention when I did the update for the last month's call is that the report is actually going to come out in June, and our contract with them goes from June till the end of September with funding and support, with funding to support education and outreach, which Dan, you probably know better than anyone. This is all new to me. It can be like internal to NOAA, but it can also be to external stakeholders to like, so ASCE. So we could ask them after the report is released in June to give a presentation here, and that can be with either the National Academy staff or with the actual committee membership itself. So hopefully we can do something along those lines. And yeah, I mean, just to be blunt, you named something that is feeling stressful to me. Like, yeah, I hope what comes out of the Academy's report isn't really at odds with like everything that we're trying to keep so aligned and coordinated within NOAA on extreme precip information. I'd love to, they're different products, they're different applications, but I would love them to be aligned. So we'll see though.
Yeah, I mean, I think the ideal is when the science supports an alignment, right? Then that way everybody can feel like, yeah, you know, we took an independent look and we basically came up with the same approaches, the same methodologies, the same concerns. So, okay, well, that sounds good. I appreciate that, Kelly.
Yeah,
any other questions or comments for Ken? I think just let me just wrap up by saying Megan and I have been kind of working on trying to put some kind of a visual representation of how the gears here would ideally mesh between the release of different versions, or the peer review version, et cetera, of Atlas 15 Volume 1 and Volume 2, and these internal deadlines that I think are really driven by the balloting process and what information has to be made available, for the balloting. Because I know from talking to Don that, if the initial balloting is they often ballot the report or the standard multiple times. I mean, there's a lot of moving parts there that kind of go beyond the technical capabilities. And so, I'm going to be reaching back out to Don and chatting with him a little bit more. But I think, Ken's presentation and Fernando, your comments have been very helpful. So, we'll see if we can get a little bit more closure around Don's thinking, I guess. I mean, I think we all came away from Boulder like, I was initially very excited that it sounded like we were going to be able to close the gap, but then as I kind of scratched at it a little bit more, I began to wonder if we were quite on the same page. So I have a feeling it's going to be one of these things where we're just going to, continue to communicate and chat with Don more, and I don't know how much specificity and commitment he can really make given the overall process.